Okay, so today we talked about how to solve a logarithmic equation. You need to solve it by setting basically each piece of the equation equal to each other. So if you start out with log of x, then and it's equal to the log of 5, then obviously the x has to equal the 5 in order for this to become an equivalent equation. And so if we have that x is equal to 5, we have to check for extraneous solutions, which if we do log 5 in the calculator, it's going to be equal to log 5 in the calculator. So that means x equals 5 would be the correct answer. For number 2, we have log base 3 of 5x equals log base 3 of x plus 4. Well, the arguments have to be equal to each other for this to be equal. So 5x would be equal to x plus 4. If we subtract x from either side, we have 4x equals 4 and x equals 1. When we check for extraneous solutions, we would have to go back to our calculator and we would have to do log base 3 of 5, because 5 times 1 is 5, and we want to know if that is equal to log base 3 of, and our equation was x plus 4, so 1 plus 4, which would be 5, and it'll tell us true. Okay? So that is a correct solution. All right, for the next one, again, the arguments have to be equal to each other, so 3x minus 1 equals x. So if I move the 3x to the other side, I'm going to have negative 1 equals negative 2x. So x is going to be equal to positive 1/2. If I go back and put 1/2 into the equation, I would have 3 times a half, which is 3/2, minus 1, which is a half. And the natural log of a half would be equal to the natural log of a half. On the next one, you have the two arguments that are equal to each other. So 4x minus 1 is equal to x minus 6. Move the x over, we have 3x minus 1 equals negative 6. You add the 1, and you have negative 5. So x is equal to negative 5/3. Now, when you're checking for your solution, if you use the inspires will show you true or false if negative 5/3 is right. If you're just checking in a regular calculator, you want to go back and type in 4 times negative 5/3 minus 1, and you want to know if that's equal to negative 5/3 minus 6. So you can do that on a regular calculator. This would be negative 20 over 3 minus 1 equals negative 5 over 3 minus 18 over 3. So if this is 3 over 3, we change the 1, this is going to be negative 23 over 3, and this is going to be negative 23 over 3. You have to change the denominators. So if you don't have a calculator, you're going to have to do it by hand. And since they are the same, and we put in 5/3, that is a good solution. All right, the last few on the page are solving the equations by exponentiating each side. So on this one, you're going to have to convert. So you're changing the log problems into exponential problems. So remember, if there is no base, the base is 10, and we're going to kind of recycle. So we're going to do 10 to the 3rd power equals x. Okay, so then in your calculator, you would have to do 10 to the 3rd power, and your answer would be 1,000. Okay, so x is equal to 1,000. Now, on these, you want to, you can check for extraneous solutions, so you can put in your calculator the log of 1,000 and hit enter, and it'll show you that it's 3, so it just shows you that it's correct. On the next one, again, we're going to start by recycling, so we're going to do 4 to the 2nd power equals x, so this is going to be 16 equals x. On the next one, we're going to do 2 to the 4th equals x minus 1. So 2 to the 4th is 16 equals x minus 1. So when you add 1, you're going to get that x is equal to 17. On the next one, we're going to, again, recycle. 3 to the 5th equals 3x. So you have to do 3 to the 5th first. I believe it's 243, but I want to check to make sure. 3 to the 5th is 243 equals 3x. So then you would divide by 3, and x should be equal to 81. Okay, on this one, remember if there's no base, it becomes 10. So you're using base 10 and you're recycling again. Oh, just kidding. Haha. This is one you gotta be careful with. The plus, that is not in parentheses. And because it's not in parentheses, the first thing you need to do is subtract 4 from each side. Okay, if it were in parentheses, then we can do it how I started. But because it's not, this is actually log 7x and then plus 4 equals 5. So this is the part that's that's part of the argument. So because it's that, we have to take away the 4th first. So this is going to be log 7x equals 1. Now we can recycle. We can do 10 to the 1st power equals 7x. If the 7x plus 4 had been in parentheses like the next one, then we could have just done what I was starting to do, which was start with base 10 and recycle to begin with. So now we have 10 equals 7x, and so x is going to equal 10 sevenths. And the last one, first thing that I would do is I would make that into one log. Since they're both log base 6 and your rule says that when you're adding you actually multiply these two together, this is going to become log base 6 of x times 2x minus 6 equals 2. Okay? Remember that our properties of log says that whenever you're multiplying and the two are the same, you can condense that into 1. So this is going to be 6 to the 2nd power equals 2x squared minus 6x. So this is going to be 36 equals 2x squared minus 6x. We're going to move the 36 over so that we can factor it. And I am going to take out a 2 so that this becomes easier to factor. Ooh, that's 18. So I'm going to factor out the 2. So now I want to find two factors of negative 18 that add up to negative 3. So that's going to be a minus 6 and a plus 3, which means that my two answers are going to be positive 6 and negative 3.